In order to figure out if CH2F2 is a polar or nonpolar molecule, draw a Lewis diagram to help visualize how the atoms are bonded in this molecule. Before drawing a Lewis diagram, refer to the periodic table of elements to determine the number of valence electrons in this molecule. The total number of valence electrons in CH2F2 is 20, 4 electrons from carbon, 1 electron from each hydrogen atom, and 7 electrons from each fluorine atom. Next, draw the Lewis diagram using the least electronegative element, or the atom that can make the most bonds, as the central atom. Which Lewis diagram best represents the actual model? Keep in mind, Lewis diagrams are limited to 2 dimensions, while actual molecules exist in 3 dimensions. To better visualize a 3-dimensional molecule, let's take a look at the ball and stick models for both diagrams. Notice that option A and B are represented by the same molecule but from different perspectives. Here is the ball and stick model using the perspective of option A. Next, here is the same ball and stick model after rotating it to match option B's perspective. To determine the polarity of CH2F2, we must draw dipole moments for each bond. Dipole moments show the direction of the greatest electron density. To draw a dipole moment, start the arrow at the positive end and draw the point of the arrow towards the negative end of the bond. Notice that the lengths of the dipole moments differ between the carbon to fluorine bonds and the carbon to hydrogen bonds, because a longer dipole moment means a more polar bond. Next, add the vectors together to determine if the molecule has a net dipole moment. Begin by drawing the first vector, paying attention to the length and the orientation. Then continue by drawing the second vector, starting from the head of the previous vector. Continue to draw vectors until all are used. If the head of the final vector is located at the tail of the first, then no net dipole moment exists and the molecule is considered nonpolar. Seeing that the 2 diagrams result in 2 different answers, how do we determine which is correct? Notice that option A positions the fluorine atoms at a bond angle of 180 degrees, but the 3-dimensional ball and stick model clearly shows the fluorine atoms at 109.5 degrees. Therefore, option B best represents the actual model, and CH2F2 is a polar molecule. Although option A and B represent the same molecule, option B's configuration results in the correct polarity determination.